Okay, let's get going. It's 6:16. This is video 130, and we're going to talk a little bit about something that's important. I'm not rushing everything, okay? You'll get me right. This will just be practice on practice, things that you're going to have to do anyway in your assignments. So the discussion is higher degree and complete factoring. And the one on the left will be complete factoring. I'll just show it to you briefly. And the one on the right, I worked out, and I'm asked to factor something that comes to a higher power. So let me box it, because I did the work. Sometimes that helps the kids see things a little better. And I'm told that it's factorable. So that's a really important topic that, maybe we could do in class. It would be so much better if we could have multiple choice in the back and forth on what really factorable is. But anyway, the Regents told us this is factorable, so factor it. So what's the difference? It's to the fourth degree. So this is a trinomial degree 4. And we always were doing trinomials quadratic, that is degree 2. So keep that in mind. You can factor any degree if it's factorable, okay? Whether we can actually do it, because some factoring is very difficult, is another story. But if it's factorable, it's factorable. So I look at this, and I just treat it with the same way I've been doing all along. 1 times -8 is -8, as you can see here. And the middle term is +2. So it's got to be a positive times a negative, where the positive is bigger than the negative. So many times we've taught you that. And so 4 times -2 is -8. So I broke it up over here. 4 minus 2 is +2. In any order, as we discussed many times. I factored the first 2 terms, placed the second term over here, factored it out, and there's my factorization. X squared plus 4. In other words, this is the answer, so to speak. And then, I don't always do this, but I foiled it as a check. I could have divided, same thing. I get my check. So there we go. You're made aware of the fact that just because you're 4th degree, 5th degree, whatever, you still can be factored. And this was an easily chosen example of what we did. So there you go with that, and just bringing it to your mind. And here we go on the other side. A topic that's more important in the Regents, talk much more about it, is I look at this trinomial, and it's a cubic trinomial, and I get a little alarmed. The powers are the odd powers starting everything. The coefficients look kind of big. It looks like a real mess. I'm multiplying this times this and trying to figure out what gets to 6 in the middle. And so here we give you the warning that we give to all high school freshmen. Look at what you're doing first. See if the terms are coprime first, so you can simplify before you start to factor. So let's go over what we know. We know this is factorable because they told us to factor. Power is bigger than what we're used to. However, don't you notice that all the terms are even and that all the terms have an x? So high school freshmen have to be able to do that. You have to be able to simplify it. That is, do the monomial factoring first. And when I do that, everybody see what I got there? Working backwards, or you could do it the other way that I showed you. Okay? This way seems to be preferred by most kids. Now check yourself. This times this is this. This times this is this. And this times this is this. So this is partially factored. They never use that word. It's factored. However, to go back to the title that we used here, it's not completely factored. And complete factorization is a very important topic to them. You'll be asked to do that many times. So that means that they're telling you that this is factorable. So I have to work this one out now and figure out what's going on. And can this be factored? Well, they're assuring me I can. So I work backwards here, leaving this out. And I try to find out that 2 times 2 is negative 4, so it looks like 4 times negative 1, 2 times negative 1 is 2. Oh, there's the 4, excuse me. 2 times negative 2 is negative 4, and positive 4 times negative 1 equals 3 when I add them together. There it is. Play around with it. Get it. I got confused when I saw the 2 here, just briefly, but I remembered that it's negative 4, and negative 4 plus a positive 4 plus negative 1 solves the key. So we'll rewrite it any order. There's plus 4x, there's minus x, and there's minus 2. Okay? And now we factor again. And there's 2x times x plus 2. Rewrite the x plus 2. And then use the negative 1 to fill it in. And so the complete factorization is 2x times 2x minus 1 times x plus 2. And this will have meaning down the road. This is telling you that there are 3 solutions on the x-axis, and down the road you'll learn that, not that far down the road, and that this is a different shape from a parabola. It looks like a cubic function, but again, that's the joy and honor of your next year's teachers to be teaching you that stuff. So this is the same as this. And again, you can check it. You should occasionally at least check these. And since I got quite a bit of time, I'm going to do another one just like this. And then we're going to sort of like put on the brakes here. And I'll go over later the assignment from yesterday. Maybe I'll do 1 or 2. Certainly put out the answers. I'll give you more Regents work, and then we'll try to fit some of this new stuff in, although it shouldn't be all that new. So let's erase over here what we did before, the original problem, where it's a quartic, that is, degree 4. You should be very familiar with my vocabulary now. You should feel comfortable talking about these polynomials. And now you're learning to factor them. And so I'll do another one very similar to the one I have. And then you need practice, right? We all agree to that. So we'll just briefly clean the board here, just enough so we can get the work in and get right to work. And here's the next example, which I'll write on the board here. And this turns out to be 6x cubed minus 3x squared minus 3x. Okay, so it's really the same game, but really helps to get practice. Like I said, we all agree to that. And again, once you understand the first example, you see the same thing, is that if I multiply this times this, and, I'm just working in a way that isn't necessary to do the math. Would it work? Yeah, but I'd have to be playing around with the x, and eventually I'd have to factor everything out. So they all share an x, and they all share a 3. So 3x factors out. That's your monomial factorization. What's left? 2x squared minus x. Double check yourself there. This times this is this. And what's left over here? Minus 1. So let's double check. This times this equals this. This times this equals this. And this times this equals this. They're equivalent. How many times I had to say that, right? So now I got to figure out 2 times negative 1. And what adds up to negative 1? Negative 2 times 1 works. Remember, the middle term is negative. Most people end up playing around with it like I am here. What's wrong with that? I do the math. Sometimes it's done. Sometimes I'm working it out. And there it is. And so I write out the 3x, which has been factored out. And then we have 2x squared minus 2x plus x minus 1. Again, you can check for equivalency. And finally, 3x And now I'm factoring out the 2. There's the 2 and the x, and that turns out to be x minus 1. Rewrite the x minus 1, and what number gets that done? Plus 1, since it just repeats. Okay? Some kids get stuck here, I might point out, but 1 is the only factor of x and negative 1, and you need a number here that works. So now we put everything together, and I get 2x plus 1 times x minus 1, and I gave you quite a bit of math this morning that you can think about. So you'll get a little bit of practice on everything with the negative 180 rotation that I talked about, and you'll get a chance to practice some of these, which is complete factoring, and then we'll have to move on to special cases, they call it, which we've seen quite a bit of, and I'll talk about that. But maybe we should just leave this here and give you a little bit of practice in addition. So maybe 5 Regents problems and 1 or 2 or 3 of these mixed up with a negative 1 there as well. So we'll work on that today.